Got it? Okay, dangling. Who loves to dangle? Who loves dangling pointers, references, or whatever? Dangling string views. So in my talk yesterday, I introduced the term designating types to get to have a summing up what dangling, everything that can dangle potentially. And returning those types, it's very easy to get yourself in the loop and in the noose and dangle yourself. And for example, writing classes deliberately to dangle is not that hard. Just if you consider we have that get member functions, remember get always say here be dragons because you break encapsulation a lot of times. And to figure out if we actually dangle, I made a side effect destructor to see what happens. And the problem is people find it attractive to use auto-ref to bind to temporaries and keep them alive during your scope. That's something you should actually no longer do because it's very easy to shoot yourself in the foot because you immediately dangle, like this piece of code is doing. Even the standard library has interesting functions that can provide you immediate dangling, like taking the iterator begin from a temporary vector object, which is immediately invalidated after the semicolon and gives you nice undefined behavior. The problem is it's very hard to detect such undefined behavior. And remember, .get breaks encapsulation. When you are doing code reviews, I learned that from Tony, always look for .gets because their encapsulation is broken. Now, we can repair that. If we have a member function that returns something from the guts of an object, like star this or data managed by the object, we can actually make sure it's never called on the temporary by making it ref qualified. And that's a feature we introduced in C++11 and have not yet adopted in the standard library throughout, where it might be very reasonable to have it. And with that change, actually my example from before, if we call .get and then the value where we might get immediate dangling, it's no longer compiling because we no longer can call .get on a temporary object with the ref qualification. And we have all the standard library where it's still missing, and even the defaults we have are wrong. So ref qualify member functions returning a designating type, and maybe we should write a proposal to make the default assignment operators be ref qualified because they return star this, and that can be a temporary transmuted by the assignment operator to L value, like here. So we have an assignable class, perfectly default behavior, just a side effect destructor to recognize. And this test case actually fails because the member of the now dead assigned angle thing is actually set to 42. So that's undefined behavior. Don't do that at home. That's why it's reddish. But that's very easy to get to. So maybe the default should actually be ref qualified assignment operators to make sure that you never call them, never capture the reference, an L value reference to a temporary that you created on the fly. So instead of good, rule of 6, make it better by ref qualifying your assignment operators. Make it future-proof. I don't know if it's better, but let's try it. That's it. All right?